Hello everyone, welcome to the channel, and today we'll be solving the longest balanced substring 1 problem on Leetcode. So I'm going to restate the problem to you. So in this problem we are given a string which consists of lowercase English characters, and we have to return the length of the longest balanced substring present in S. And for a substring to be balanced, the condition is that the distinct characters in the substring should appear the same number of times. So let's understand this with an example here. So for the first example, we are given A, B, B, A, C, right? So for this string, we can see that if we take this particular substring from, and let me just write down the indexes, from index 0 to 3, we can just see that the number of distinct characters is 2, right? And each of the distinct character have the same frequency. So A has a 2 frequency and B has 2 as well. And you can try this for other cases as well. You can take, for example, you could have taken this substring as well, BB, where the only distinct character is B itself and it appears twice, right? This is also a valid answer, but in here we have to print the longest one. That's why we took ABBA. And even a single character is also valid, but it might not be the longest substring present in the string we are given, right? So what we can do is first list out the condition for what makes a substring, in fact, a balanced substring, right? So condition for a substring to be balanced. So the all of the, okay, let me just take another clue here. Distinct characters in a substring S, starting from the ith index and ending at the jth index. That's how we denoted for substring I till j should have the same frequency, right? And it's also very important while solving a Leetcode problem, you should look at the constraints given to you. So here the constraints given to us is that the length of the string we can have can go from a 1 till 1,000, right? So we have to think of our approach in such that its time complexity fits this particular constraint. So let us just think of a brute force approach first, right? If we had to solve this problem in a brute force fashion, what could we do, right? So as let's take this particular example here, right? So for this test case, what we could do is that we could generate all the possible substrings, right? And for each substring we could have checked if that particular substring is balanced, right? So what we could do is generate or go through all possible substrings, right? And for each substring, for each we can check if it's balanced or not, right? So again, this is the brute force approach we can possibly comes to one's mind when they are thinking of solving this particular problem, right? So let's find out the complexity of this approach. So for generating the all possible substrings, it will take at least O of n square time, right? Since what to generate all possible substrings, we will let's say for this particular example that we have, we'll have to fixate a point, let's say I, and we can have j at the same position or the next one, right? What I'll do, you'll have to fixate one point which is starting point, and then expand the j from, let's say it goes from the first index to the second and third and the fourth, and after that it's reached the end, you increase I and j starts from all the way here and repeats the same pattern again. So as you can see, it's kind of O of n square motion here, right? We are fixating and then we are iterating the end pointer as well. So it takes O of n square to get through all of the possible substrings, and for each substrings we have to check if it is balanced or not. So let's say if we are doing it from the ground up, so for every I comma j range, if we build a frequency map to store the frequency of each distinct character, it will take O of n time. So if you multiply that, we get the final complexity to be O of n cube. But as we saw, we were given this constraint that the length can be till 10 cube, right? So 10 cube is 10 to power 9, which is slightly out of our bounds. So it has to be less than 10 to power 8. Our algorithm should run in less time. So can we think of something else? Can we optimize this maybe into of O of n square solutions so that it runs in maybe at worst takes 10 to power 6 number of operations, which fits right under 10 to power 8. Can we do that? Yes, we can. So instead of what we can do, instead of building a frequency map for each range from the very ground up, what we can do is do a simple optimization. Maybe we don't have to calculate the frequency map for every time, let's say j moves from this position to this position, since we already let's say for our frequency map, it already has the frequency of characters from here to here, right? So we'll just have to append or update the frequency of the new character which is here, right? So in this way it will reduce our time complexity from n cube to O of n square. And one more important thing we can come across this is that we are taking advantage of the fact that there are only 26 characters in English language. Because in the worst case as well, we'll have to go through each character, right, and check its frequency, and we have to check if all of the character present in the particular substring have the same all the distinct characters have the same frequency, right? Since English language has only 26 characters, it will just take O of n of 26 in the worst case for us to calculate that. So our final complexity will be O of n square into 26, which is roughly O of n square only, since this is constant. Otherwise, if we were not working with, let's say, alphabets, right, if it would have been numbers, then numbers could range from let's say 1 to 10 to the power 5 or whatever the constraints are, right? So it is not constant. So again, it will take probably in the worst case n cube only. Since we are working with alphabet characters, we have come up with this approach, right? So here I will write out the pseudo code for this particular problem, and we can go through uh, the code later on in this video. So what we can do is we can have a loop, right, for let's say int I equals to 0, starting from 0, and it's always less than n, and we can keep incrementing it, where n is len of s, right? And inside this we can have in a loop j equals to I. Since we are starting from j equals to I, just because a single character can be also a valid subarray as well, right? And j equals till n-1 as well, and we keep incrementing it. And here, since this marks I marks the starting of a substring, here we can have a hash map or a frequency map, we can say an order map. You can okay, let's just define a frequency map here. We can get to the technicality of the particular coding language later on, since this is a pseudocode, right? What we can do is we can add the frequency of this particular character at jth index, increment it or update it, right? And after every update, we can just check if the current I to j range is valid or not. So we can just check, we can have a helper function, right? If is balanced, and we can pass our frequency map to it, and if it returns true, we can let's say, or we can have a variable called answer to store the length of the best result till now. If our current substring is valid or balanced, we can have answer to be the max of itself, j minus I plus 1. How did we come with this formula? Since let's say we are working with a substring, right? Let me write down the index, right? And we have string a b b a, right? And c. We have to find out the length of this particular substring, right? So let's say I is at this position and j is at this position, right? So the length of this particular substring can be calculated by j minus I plus 1. For here it will be 3 minus 0 plus 1, which is 4, right? So that's how we got this particular formula here for calculating the length of a particular substring. And here we can close this if statement and this for loop and this for loop as well, and at the end we can just return our answer, right? And we can later on all right, so since we have discussed the basic structure, right, we can also have a look at the isBalanced function, that the helper function that we are using in the main code. So it will be a bool type, since it will return if a true or false, depending if the particular frequency map has same number of frequencies or not. So bool is balanced will have the frequency map, right? And we'll have target to be the, let's say, frequency of the first character present in the frequency map, frequency of 0, frequency maps first elements count, right? And we can have a loop here for each uh, each element in frequency, for each key or element or character, we can say, in frequency map. And if uh, frequency of ch is not equal to target, we can return false. Otherwise, our is balance will always return true. Right? So this way we have solved a problem in overfine square, and I'll just take you through the actual C++ code for this problem in just a second. So here, as you can see, we have the code for this particular problem in C++. So again, we did the same thing. We have initialized two nested loops, I going from 0 to n, right, and j going from I to n. And every time we increment inside the inner loop, every time we go through, we update the count of the element present at the jth index, and we check if till now the frequency map is balanced or not. And here is the code of the is balanced function. We check if the frequency map is empty, then obviously we have to return false. And if and we set the target to the frequency of the first element present in the frequency map, right? And we can check through this loop if every element present in the frequency map if it does not have the same frequency as the target, we return false. Otherwise, after this loop ends and we have not returned false, it will return true. And here we'll just update a max length till now and return that in the end. So yeah, that's it for this video. I hope you liked it, and stay tuned for many problems ahead. Thank you so much.